Okay, so we continue the material in chapter 10. And let's recall, last time we talked about scalar inner product or dot product. So, and it's related to the next topic. So we have two vectors A, A1, A1, A2, A3, B, B1, B2, B3 in R3 space. And we could define the dot product. So dot product is defined by this way. Each component we consider their product and consider their sum. So it's easy to see E will be also equal to the inner product. And it's a scalar, it's a real number, And another notation or definition in this one, if we say A and B, they are orthogonal means that the inner product equals 0. And in this case, we could use this notation. It means that these two vectors are orthogonal. And we have one result. In this case, we know that if it's our vector A is our vector B, then the angle between these two vectors is 90 degrees. The theta is 90 degrees. In this case, theta equals 90 degrees. In this case, okay, yeah. So last time we talked about this one, and actually the general result is that for this one, cosine theta is equal to the product of their lengths, and the numerator is the inner product. General result is this one. Because if two vectors A and B, their angle is theta, then cosine theta equals this one. So use this result, we know that if two vectors are orthogonal, means that inner product equals 0, and use this notation, and in this case, the angle is 90 degrees. Yeah. And now we talk about cross product. So now we talk about cross product. Yeah. So it's in section 4. 10.4. It's in section 10.4. And here I write down the definition again. Yeah. And we still have the two vectors A, B. Then we use the notation I is the 1, 0, 0, J is the 0, 1, 0, K is the vector 0, 0, 1. And our cross product is defined this way. Cross product of A, B is defined this way. The notation in this one, I, J, K, A1 are two vectors. A is 1, A1, A2, A3, B is B1, B2, B3. So here we put down the value A1, A2, A3, the value B1, B2, B3 here. And it means that what's this? Just use the determinant is something, of course, the values A1, A2, A3, B1, B2, B3, they are values. And the I, J, K, they are vectors. But the operation is like the definition about determinant. So use the determinant, we know that we denote it by plus, negative, plus. So it means it's this one. It's determinant, so its determinant. So its determinant is A2 B3 subtract A3 B2 times I. And the second one is these two currents and these two currents, their determinant. So but we should multiply -1. So here is -1 times J. And these two currents, so it's A1 B3 subtract A3 B1. This one. And the last one is plus K. And use and consider these 2 by 2 submatrix is determinant. So it's A1 B2 subtract A2 B1. So it's this one. It's this one. Yeah, and it's exactly, we could write down this one. I is here. I is 1 0 0. J is 0 1 0. K is 0 0 1. So actually it's this one. The first coordinate is A2, this one, A2 B3. A2 B3 subtract A3 B2. Second coordinate is A3 B1. Yeah. Here is A3 B1 subtract A1 B3. A1 B3. The last coordinate is A1 B2 subtract A2 B1. This one. And it's a vector in R3. It's a vector in R3. So cross product of A and B, if we have two vectors A and B in R3 space, then inner product means it's a scalar and it's defined by this way. And using inner product, we could know the angle between these two vectors. And the cross product is a vector in R3. It's defined in this way. And when we consider its cross product, it's a vector in R3. It's a vector in R3. So of course we will ask the question, for the cross product of A and B, what can we say? What can we say about their cross product? Their cross product.